Hello, this is Tim McAllister, Director of Business Development here at Mocana. Thanks for joining our webinar today about IoT security best practices, migrating away from open source security safely. Today we're joined by Srinivas Kumar, VP of Engineering here at Mocana. A little bit of background on the webinar. This is the third in our three-part webinar series on the risks and costs associated with the use of open source security in IoT projects. Today, we'll be covering how to migrate away from those open source security solutions and do so safely and quickly. Okay, jumping into it, just a couple of things. If you have a question, please submit it over chat. That's the best way to do that. This presentation and a complimentary white paper will be available at the end of the webinar. Also, you'll be able to view this webinar on BrightTalk after this session. A bit of background about Srinivas Kumar, our Head of Engineering, who leads our engineering and development. He's led engineering and product development at several security companies. He was also an EIR at SRI and was the head of engineering at an identity access control company, Applied Identity, which was acquired by Citrix. He's also been a contributor at Nortel, Lucent, and Transwitch. He holds numerous patents in the field of cybersecurity and has worked in both the commercial and defense sectors. Most recently, he co-authored the white paper, Endpoint Security Best Practices, which was ratified by the Security Working Group of the Industrial Internet Consortium, also known as the IIC, and that has a membership of over 200 of the top-tier global industrial OEMs. So before we get started here, and while we go through this, we'll be asking a number of poll questions. And on the first poll question, I'd like to get a feel for who's out there on the line. So I'm going to pose a poll question now. And what part of the business are you associated with? Are you in the OT, on the operational technology side, either running production environments or developing products for OT? Or are you involved in the IT side and supporting infrastructure or some other area? And then just to provide some context before Srinivas reviews some of the significant challenges with the use of open source security and then how to migrate away from it safely. So open source is not just free and available. Our customers found that it's deeply integrated into some of the top embedded and IoT platform products. Some examples are IoT platform gateways such as Microsoft Azure, AWS, as well as VMware's Pulse IoT. Another good example that we'll delve into a bit further on in the webinar is Wind River's VxWorks, has OpenSSL deeply integrated, and there are some challenges that Srinivas will walk through with us and what to do about it, and some solutions that Mocana has developed. You know, in that particular case, one of our key customers was challenged, and in their words, they had to hack out OpenSSL from this embedded firmware solution. So that led to many questions and unknowns, as they were working to develop their products. So Srinivas, could you take a minute and tell us about the use of free open source security and some of the risks, challenges associated with that?
Thanks, Tim. So fundamentally, the challenges that we see in the emerging IoT space, which comes outside of control of IT administrators, which typically in an enterprise world with managed systems, where you put open source stacks for web servers and so on, were more controlled. So you had open source in a controlled environment. And now when you look at trying to put the same open source in a loosely controlled or loosely managed environment, which is in the field on IoT devices, it exposes a lot of challenges in terms of visibility, in terms of mitigation, and in terms of even knowing that the exposure has been exploited. Right. So, and fundamentally, the factors that lead to this begins with the large and complex database that historically open source has built up. Through several versions, we have pretty much seen how difficult it is from a management point of view to go and fix problems in every version of OpenSSL. So firstly, you have to know what version of OpenSSL is in what device out in the field. And with millions of devices, you really don't know how you're going to backport and patch every NIST CVE that's known to hackers. So the volume is the first challenge. Secondly, from a developer's perspective, it is a rather complex directory structure with no specific coding guidelines, styles, very loose, non-object-oriented with no data abstraction, which means that bad practices in terms of how a service or an application might leverage direct use of data structures, which leads to the type of vulnerabilities that you see. Right? So that openness is also something that hurts you in the way applications try to expose the memory structures which are getting exploited in buffer overflow attacks and so on. So these are the general challenges of OpenSSL for a developer and also from an operations point of view.
Thanks, Srinivas. So vulnerabilities matter. One example is the EU's launching GDPR, the General Data Privacy Regulation, and it begins May 1st of this year. So we found a growing number of our top-tier global OEMs that sell products across the world actively working with us to eliminate use of all open source security solutions that have been integrated in their products. So that's just kind of one trend that we are directly involved with and see up close and personal. So, this report that we leveraged here and are highlighting shows that an average of 3 vulnerabilities per month were reported against OpenSSL. So that's just, it might not sound like a ton, but when you have products deployed with end customers in operational production networks and environments fielded, and these are embedded products, there is a significant challenge associated with how to manage, patching and what are the risks associated, from the end customer's perspective, the one running these production environments and networks, what risks do they attribute and associate, and how do they weight a security vulnerability patch with keeping their network operating, right? And any change that might be introduced into a patch and the serious life-threatening potentially impacts that may have. So, then you tie that vulnerability rate to the amount of time it takes to remediate the vulnerabilities, and there's significant cost, risk, and huge operational effort to manage not only an OEM manufacturer's response, but also work through the support of their end customers in their remediation process, right? So now would be a good time for our second poll question. For those of you developing products, how many of you have deployed or are considering deploying an open source security solution? Yes or no? Srinivas, I'll let the folks have time to answer that question. What's your experience been with customers working through remediation and vulnerabilities, and what challenges have you seen?
The first challenge with remediation is being able to not only reproduce the problem, which is difficult from a developer's perspective because of the various versions of OpenSSL, right? And being able to then fix it in one version and backport it to several other versions and then regress it. So this is a QA challenge. One is to be able to provide a patch, and the second is to be able to actually regress it before you can push it out into production systems.
Great. So change is hard, right? Patch management is hard, especially with fielded production systems operating in these production environments. Product introduction cycles are measured in several months to years. So how long would it take to manage a patch, develop, provide, and distribute? Right. Some questions to ask yourselves. How long would it take for your end customers to consume and then deploy it, or would they deploy it? Right, depending on the industry and the challenges, the operational risk they'd face by any changes to their operating network. And then, so can you, Srinivas, take some time and explain some of the challenges, more that process of quality testing that a OEM's end customer might have to go through before they'd make a decision to release a patch for a security vulnerability?
Yes, so a lot of the vulnerabilities can be natively in the system because of the way the applications were using the OpenSSL APIs. So there are the secure ways and the insecure ways. And typically we have seen applications that try to not use the APIs but bypass APIs and directly access data structures of OpenSSL. Eventually, over some kind of an upgrade where they move from one version to the other, the same application could start misbehaving. Or it could expose attack surface for malware. So that basically makes QA pretty difficult if you're only trying to patch the libraries without being able to qualify the applications that use those libraries.
Thanks, Srinivas. So I'll take this opportunity to ask another poll question. What's your biggest perceived challenge with the use of open source security? And now we'll transition on what to do and how to migrate away from open source security safely. And let's also now take a minute to review some of the poll results we have in. So for the question, what part of the business you're associated with, 33% in IT, covering internal and externally facing systems. And the rest, can you go back to that? And 83%, oh, excuse me. No, the first one, sorry. Yeah. And then 66% other. So, next one. And then and the second poll question, for those of you developing products, how many of you have developed or considering deploying open source security solutions? 16 of you responded yes, and 83% responded no. And then regarding the question, what's your biggest perceived challenge with use of open source security? 40% responded brand risk associated with your product susceptibility to the latest vulnerabilities with open source security, GDPR liability. 20% responded support costs associated with supporting open source security. 20% also responded back lack of product differentiation, only adding limited security functionalities to your products. And 33% of you noted certification to the latest cybersecurity standards and mandates were a concern. Thanks. All right, let's see. So at the end of the day, Mocana provides roughly 3 pillars enabling essential security for connected systems and devices. First, we're enabling our customers to create self-defending devices, right? And I'm going to let Srinivas kind of get into some of the details here. Secondly, provide a cyber developer platform that enables accelerating development and deployment of secure solutions. And then third, enabling a cyber orchestration platform that provides scalable, secure lifecycle management for devices, not only device to cloud as we show in this image, this topology, but also cradle to grave, right? So how, it's even beyond security. How do you scale implementation in greenfield, in brownfield, right? So Srinivas, would you like to kind of walk through the high-level architecture and approach we take?
So what you see is an ecosystem where the IoT devices can either be endpoint devices, what is typically called as a mist, and then there's the fog with the gateways. And essentially, these devices connect up to a services cloud, whether it is hosted by the enterprise data center or through a public-private cloud. So in this maze, what we see is a wide variety of chipsets and operating systems and secure elements being deployed across the different verticals and the different form factors of devices. And we classify devices all the way from a resource-constrained device, a $1 device, to a $1 million engine. So there's a broad spectrum. And increasingly with the FPGAs and the SOCs, most of these devices are purpose-built, whether you're using it for a camera application or a smart city or a smart factory. And the device vendors want the flexibility to optimize the manufacturing cost. And so they pick their operating system, they pick their chipsets, sometimes it's the MCU or the SOC or a secure element. What Mocana provides from an OEM perspective and application developer's perspective is a plug-on stack. And what that stack does is it enables the authentication and enrollment of the device into the cloud, into the device management service, which is the first step in onboarding a device. And that process really authenticates the device as a genuine device to the device management service and certifies that device with a certificate that now becomes a basis for mutual authentication of the device when it connects to connected services. The second thing that an application has to do is use cryptography. And that requires a cryptographic key, and then the lifecycle management of that key becomes a challenge unless the key can be associated with a certificate, because certificate lifecycle management is an industry standard, and there are protocols and services to do that. Whereas raw key management is a very cumbersome process. So we provide the ability to generate keys locally on the device if you have a secure element, or remotely using a standards-based protocol called enrollment over secure transport, which is based on RFC 7030. So once you have the cryptographic artifacts, then the transport stack, the entire TCP/IP stack with the SSL, SSH, IPsec, and so on protocols can leverage that stack, and so can applications written in C, C++, Java, C#, and so on. So now essentially the responsibility of protecting the cryptographic keys is in the secure element, and the Mocana stack ensures that that cryptographic key is not compromised. Because if that key is compromised, you end up compromising the device, and where you're using such keys for secure boot, you end up breaking the device. And now once you have the keys protected, the certificates to manage the device, you have encryption and confidentiality, right? So the data confidentiality is provided with encryption. The data integrity is also provided with signing keys. And all of this can be done either using a hardware secure element or software crypto, which Mocana provides as a FIPS 140-2 level 1 certified stack. So you're basically protecting the device in a way that a compromise can be prevented, and you can onboard and offboard devices and mitigate the threats through remote management.
The what?
Forward.
So here is basically the process by which you would enable our stack, install our stack on the device. Mocana provides source code, which you can optimize based on the resource constraints on your device. The resource constraints can be limited flash, it can be limited SRAM, battery limitations, and so on. And based on that, you would optimize the code. You would pull the code into your development environment, which can be an integrated development environment. As an example, it could be Wind River Workbench, it could be Eclipse, it could be Visual Studio, it could be Renesas E-Square Studio. We provide the project files, the solution files. And once you pull that into your environment, you select what ciphers you want to pick, and then you build it, and you get an optimized binary that you then load onto your device. So it's a very simple three-step process where you receive our source code, you pull it into your environment, you decide what ciphers you want to select, what key sizes you want to select, and then you compile it for your target. Out of the box, we provide an OS abstraction layer for several RTOSes, all the way from VxWorks, QNX, FreeRTOS, ThreadX, and so on, Nucleus, and so on, and pretty much all variants of Linux and Windows. And where you have a custom OS, we provide a stepwise porting guide where you can port our OS abstraction layer to your operating system. And then the rest of the application uses the abstraction layer, so it just becomes a simple compile with your build tools. So in terms of the actual modules that you not only optimize, but you pick, it depends on your use case. We provide different layers of modules, all the way from the trust abstraction layer, which allows your transport stack and applications to be agnostic about the underlying secure element.
Can you make one note on that? So in the previous webinar, you described the challenges related to not using abstraction, right, within OpenSSL specifically. Can you just say a bit about that? Because there's a significant benefit, security benefit, that you've provided when you're delivering this trust abstraction platform.
Sure. So when you deal with OpenSSL, the first and pretty much the major enhancement that you look for is hardware acceleration. But hardware acceleration is very much a function of that specific chipset, whether it's a Cavium or a Freescale or an XP and so on, which means you have many stacks. And for every application on every platform, you have to build a very specific library, which makes it a challenge for porting, not only across operating systems, but also across the chipset. By creating the abstraction layer, we not only make that migration of applications across hardware pretty much like a virtualized platform, we also extend the capabilities to a lot more than acceleration, because you now want to do key management, secure key storage on the chip. You want to do certificate storage on the chip. You can do trusted measurements from the chip, right? And you can sometimes even offload certain transport functions onto the chip, in addition to the acceleration. So it gives you the ability to look beyond acceleration and leverage any and every capability of the chip, whether it is locally on the device or remote. So if you have a case of a hardware security module like a HSM, and you want to migrate your application from a device to the cloud, or vice versa, your application does not have to be modified. The abstraction layer takes care of that migration. So that's the major advantage, that our entire transport stack leverages our abstraction layer. So you don't have to rewrite the transport stack or the application when you decide that you want this solution to work on different form factors, different hardware, different chipsets. Right, so we start at that abstraction layer, and then what we provide is all the way from very boot time, an option where you can insert our verified boot code into your boot process right at the first stage bootloader with just one API call. And that basically provides you a full PKCS, PKI-based secure boot mechanism with signing and verification based on your choice of signing strength of the keys. The key size, the cipher type, the hash function is fully user configurable. And we provide a secure update mechanism, which also uses a PKCS standards-based, PKCS 7-based enveloping. So all updates to bootloaders, to firmware, to operating system, components, to configuration files, and application happens through multiple signers and encryption, which actually allows you to modify a bootloader. So even if the keys of the bootloader was compromised, that device is not bricked. We provide multi-key protection, so it takes multiple key compromises to brick the device, giving you enough time to remediate through a secure update. And that basically gives you full remote control of managing the boot integrity of that device. And once you have the boot integrity, then you have the tamper resistance that protects your cryptographic artifacts. And then you have a choice of transport, depending on your application, whether you want to use, let's say, HTTPS, in which case you could use our SSL stack. Or if you want to just use device-to-device communication over LoRaWAN or Bluetooth and so on, then you need DTLS as a protocol. Or you might do message PubSub with MQTT and AMQP, in which case you essentially need a cryptographic stack that can do signing and verification of the messages at high speed. So we provide our crypto engine, which takes less than 1/5 of memory compared to open source equivalents. So the entire transport stack of SSL and crypto fits in less than 1/5 of that memory space, which is significant memory reduction on resource-constrained devices, because the more memory you put, the more it's going to drain the battery. And so that is an issue. While memory might be getting cheap and Moore's law might still be true, Moore's law also drains your battery. So that's where you can be very selective. If you want to do IPsec in a process control environment, you can leverage our stack, which takes a very minimal amount of memory. And then on top of that, you want to have authentication protocols, because these devices are headless devices. In the IT world, the user has the password or a two-factor, and it is the user that authenticates based on what the user knows. But in a headless device, there is no keyboard, and the device is what the device claims to be, which can be a serious threat because devices can be cloned or devices can be tampered with at manufacture by rogue nations and so on. So what we provide is a various set of authentication protocols, all the way from certificate-based authentication protocols to radius and other forms of authentication methods that are supported by the EAP standard, which is an extensible authentication protocol standard, and it gives you dozens of methods, all the way from LEAP, PEEP, SIM, AKA, TTLS, TLS, and so on. That gives you flexibility in how the device can authenticate to the gateway or to the cloud service.
So it supports their legacy authentication mechanism and makes it extensible into these new genre of IoT and connected devices, right? So it operates as that kind of yet another abstraction, or extending that capability down into the IoT, fog, edge, etc. So can you say, before we jump off this topic right here, how about a single root certificate assigned to a device, and kind of the differentiation that Mocana's approach can provide?
Now, when you use a device which is authenticated, the first thing you need to give the device is a certificate, which will become a mechanism for device-level updates to be pushed by an OEM. Because all the way from firmware to the operating system to the application, the supply chain is what pushes the updates to you, right? So if you have a TPM with firmware on it, you really want only the TPM vendor to be pushing firmware updates to that chip. And then the same thing with bootloaders or operating system. The OEM or the OS vendor is the most authoritative source of that update. So when you have this type of mixed supply chain, you need to give the ability for device level and platform level updates to happen at a higher level of assurance with a certificate that is managed by the OEM or by the customer. And then when applications start landing on those devices, you want the applications to have their own certificates. But in order to get that certificate, you have to go beyond what is known as the certificate chain. The certificate chain only gives you assurance that the certificate was issued by the certificate authority, and you can track it all the way back to the root CA. But aside from that, when an application on a device wants a certificate, you need proof that the application is authentic and that it is running on an authentic device. And so what we provide is a trust chain that allows the application to request a certificate for itself by having its request digitally signed by the device's certificate. And that basically tells our service that issues certificates on the other side that this application is running on a genuine device and it is attesting to its own identity. And now the keys that are given to that application is only for that application. And that's one way where you could control how malware could land on that device, because it will have to identify itself and be able to use a device certificate to sign its request. So that gives, it's basically like saying don't have one key that opens your car, your house, your bank account, your vault, and so on. You want to have multiple keys. And by giving every application its own cryptographic keys, you can prevent one application compromise from compromising the whole stack.
Thanks. And this webinar is by no means an attempt to kind of delve into the depth of the Mocana solutions and some new security automation lifecycle management services that were just announced this morning. But so we'll have a subsequent webinar to provide more information on that.
So what it means to use our OpenSSL connector is that applications that are OpenSSL enabled today can migrate without having to be rewritten. So on the left side, you see application indicated in blue that uses SSL functionality of OpenSSL by linking into libSSL. On the right side, you see an application in green that is using OpenSSL for crypto functionality using libcrypto. Now, what we provide is a patched version of libSSL and libcrypto. We provide you the patches. We also provide you the patched version of these libraries. So you can either download them from GitHub and patch it, or you can take the patched version that goes through our QA. And then in addition, we provide two more libraries, the libnanoSSL and libnanocrypto. It's a combination of these four libraries that gives you the full SSL TLS engine, as well as the crypto that we provide with our stack. The two libraries, libSSL and libcrypto, are under GPL, and they are kind of like a shim of sorts, whereas the libnanoSSL and libnanocrypto have to be licensed through Mocana. But from an application perspective, with these four libraries in place, it is a simple recompile and rebuild without having to modify the APIs. And it gives you full leverage of not just hardware acceleration, but the entire secure element functionality through our trust abstraction layer.
Excellent. So, as we described, OpenSSL is already pre-integrated with a number of solutions, and this is in fact the case with Wind River's VxWorks. Srinivas, can you describe for us what's now possible with Wind River's VxWorks and the Mocana device protection?
Yeah, so what we provide is for VxWorks 6.9 and 7.0, a project file which you can load into your IDE, and it gives you the option to turn off OpenSSL and use our OpenSSL connector, which also uses a NanoSSL stack. So in the user interface, you can pretty much disable OpenSSL and use our OpenSSL connector and NanoSSL and NanoCrypto functionality. So it's a very simple click and go kind of integration into our IDE. And we have verified our OpenSSL connector with various OpenSSL enabled applications out of the box, or the curls, the wget, and LDAP, and so on.
Great. So here we've summarized how Mocana's comprehensive security solution compares with other types of security solutions. Srinivas, do you want to touch on how Mocana's comprehensive essential security allows endpoint devices to defend themselves and against the numerous threats, and outline some of the key differentiators versus other types of solutions?
Yeah, so we basically start from the common denominator of secure credentialing to verify the integrity of the device. We extend it to boot sequence, so it's all the way from verified boot. We also provide a nano firewall capability for certain resource-constrained devices on RTOSes, where the memory footprint is very small. And in industries such as process control industries, where they want to data diode the device to make sure the device cannot be tampered with externally when it is connected to the internet. We provide a full set of NIST FIPS validated encryption ciphers, all the way from asymmetric to symmetric keys, and which can be used for signing of data as well as the device. We allow full connectivity to the cloud ecosystems by pretty much rip and replace of the OpenSSL stack for SSL or MQTT kind of applications, so that you can seamlessly connect to the cloud services, whether it's Azure, AWS, Google, and so on. But the bigger, I would say, the innovations that we provide here is the secure update, which is not provided by pretty much any other solution, because we don't see a simple code signing as adequate strength of security, and so does the NIST specifications. So what we provide is a full supply chain provenance-based protection, where update packages are verified across all touch points, all the way from the provider of the package to the distributor, the reseller, the publisher, so that at every touch point, there is a digital signing that guarantees that at no point in the supply chain any tampering could have happened, at rest or in transit. And the updates are encrypted in a way that only the authenticated and the authentic device will be able to decrypt that payload, which provides IP protection, because you don't want your intellectual property to land on a device where it can be reverse engineered. So that secure update is end-to-end. It is based on authenticated devices, and in a way that it cannot be even accidentally distributed to an illegitimate device. And then the secure device enrollment, which begins with the onboarding of the device, which issues the certificates that would subsequently be required for the secure update to begin with. So those are the two things that we do to protect the device, both at manufacturing and aftermarket.
And just a note, so these capabilities that Srinivas has just kind of briefly outlined, so are contained and announced in a press release that just went out this morning, and that revolves around the automated device protection, our TrustPoint endpoint security solution, in concert with our Trust Center, the autonomous security automation lifecycle management capabilities that Srinivas just described. So cradle to grave as well as device to cloud. It kind of requires that scalable, well-rounded approach. Thanks, Srinivas. So we're close to running up against time. I just want to thank everyone for joining us in our webinar. If you have follow-on questions, please go to our website and submit them. And again, all these materials are going to be shared with you as well as the white paper, this recorded presentation, and then this webinar is actually going to be made available on Bright Talk for subsequent viewing after the webinar. And then please do join us for future webinars, and all you have to do is, if you're on our mailing list, you'll be notified, or check back on our channel here on Bright Talk for details about our upcoming webinars. Let's see. The next one happens April 25th. It is Extending Cybersecurity Beyond Data Protection, Protecting IoT Endpoint Devices and Communications. And we'll get to, again, engage with Srinivas Kumar. So thanks. Let's see. Well, just a couple notes about Mocana. So we provide security to some of the largest global OEMs in the world. We're already on and protecting over 100 million devices to date. And we'd love to work with you and explore how we might be able to help you. Again, thanks for joining, and have a great rest of your week.